Let me begin by thanking everybody involved in this. First, let me thank Mark Spivak and Francis Fallon for putting together this really wonderful special issue of Philosophy and Mind Sciences with a bunch of really excellent articles. And then let me also thank Kristen Tobias for putting together this great colloquium series. This is really fun. Um, okay, so let me just start off by saying a little bit about what John and I are up to in this particular paper and how this paper came about. And we've been having discussions about problems with the notion of neural representation. And sort of one of the issues that we'd been thinking about involved sort of alleged evidence for neural representations and really what should and should not count as good evidence. And we both had worries that a lot of what was being presented as evidence for neural representations really wasn't. And moreover, it seemed that a lot of the time researchers were sort of presupposing a representational role and then interpreting their findings on the basis of that presupposition, on the basis of that assumption. And it just seemed to us that this really wasn't the right way to go about things. And about this time, this essay came out. I need to read everybody's names. It says 8 authors: Pohl, Walker, Barrick, Lee, Dennison, Block, Meinel, and Ma. So they came out with this essay at the time that was entitled Desiderata of Evidence for Representation in Neuroscience. And of course, that's exactly what we were interested in. That was exactly what we'd been talking about. And so we felt like in this essay, the ideas that were presented actually did a great job of presenting the common attitudes about evidence for neural representation that John and I found to be deeply problematic. And so we decided to write this paper, to write up our concerns, and that's what this paper attempts to do. I think, as a lot of you know, in other writings, both John and I have expressed skepticism about certain notions of representation, including neural representation, but we really hadn't come at the issue from the standpoint of evidence, and this gave us a nice opportunity to do that. Okay, so here's just a kind of preview or an outline of what we're going to try to do, or what I'm going to try to do in this talk. First thing, I'm going to address a number of sort of preliminary, kind of foundational issues so that I can set the stage for our arguments that are going to come a little bit later. Then I'm going to use the Pohl et al. Account as a framework for expressing our main concerns about the standard accounts of evidence for neural representations. We're going to use it as a kind of a jumping off point. Then I'm going to take a slight detour in order to discuss some side issues and some foundational issues regarding our search for evidence for cognitive representations. And I'll also try to address some other issues and distinctions, like, for example, the distinction between a system's exploiting a natural relation that carries information on the one hand, as opposed to exploiting the information itself on the other hand. So there's going to be a little bit of a detour there. And then I'm going to talk about what we think investigators really ought to be focused upon in their search for evidence for representation. And then there'll be a brief conclusion. So that is the game plan. Okay. First preliminary issue is getting clear on the target of our skepticism. I think, as everybody knows, there are many different sorts of representational posits in cognitive science. On the one hand, representations are both the targets of explanation, like with memory or imagery, but they also serve as explanatory posits, as with internal maps that are posited to explain animal navigation. And they're also invoked at very different levels of explanation or analysis. They can be invoked as more abstract computational states, but they can also be invoked as subpersonal and even neural states. So keeping this in mind, we can construct a kind of 2x2 matrix that I'm showing here that captures these different notions, basically these different ways of thinking about representation in cognitive science. Now, we want to emphasize that our main concern pertains to the bottom tier of this matrix. We really don't have any problem with the sorts of representations posited at higher levels of analysis, kind of as more abstract computational states in the brain. Our concern pertains to the alleged evidence for neural representations, invoked as both explananda, in other words, as kind of targets of explanation, and as explanatia, that is, as explanatory posits. So, generally speaking, our concern is with the idea that there exists good evidence suggesting that it's appropriate to describe neural activity itself as representational in nature. Okay. Uh, Another preliminary issue has to do with the epistemology of evidence itself in science. And so we're going to adopt what you can think of as sort of the standard view that evidence for any given hypothesis is any finding or observation or fact that supports that particular hypothesis. And we recognize that the quality of evidence can depend upon a lot of different contextual factors. And for us, the main contextual factor that we'll be concerned with is the possibility of alternative hypotheses that also fit the evidence. So, for example, a footprint, let's say, might be good evidence that a particular suspect, say Smith, was at the crime scene if Smith's shoes perfectly matched the footprint. But that evidence is really substantially undermined if there are a number of other suspects who also wear the exact same type and the exact same size of shoe. Now, there's different ways you can kind of formulate the same basic idea. One way has to do with unique compatibility, where E counts as good evidence for hypothesis 1 over hypothesis 2 if E is compatible with hypothesis 1 and not with hypothesis 2. Or there's a graduate student I worked with at Notre Dame, Robin Collins, who put together something called the prime principle of confirmation. And that's the idea that evidence counts as good evidence over hypothesis 1 over H2, hypothesis 2, if the evidence is more likely given hypothesis 1 over hypothesis 2. And then also there are standard accounts of abduction, where E counts as good evidence for hypothesis 1 over hypothesis 2, if hypothesis 1 provides a superior explanation of the evidence. Now, of course, for all of these, the converse is also true, right? So E does not count as good evidence for H1 over H2 if it is not the case that E is compatible with H1 and not H2. Or with regard to the prime principle of confirmation, E does not count as good evidence for H1 over H2 if E is not any more likely given H1 than H2. And then, of course, E does not count as good evidence for H1 over H2 if it's not the case that H1 provides a superior explanation of the evidence. And just as kind of a preview, that's the line of argument that we're largely going to be focused upon. Okay. Another thing we need to get clear on is sort of what is the right way to frame the representational hypothesis and what kind of modality is appropriate here. And sometimes things are presented in different ways, and I think it helps to get clear on exactly what the most beneficial way is to think about the modality of the representational hypothesis. So one option is that we absolutely must treat these neural states as representations. Well, we tend to think that that's too strong because given that representation is a functional notion, in biology, it's always possible, at least in principle, to avoid functional explanations and simply adopt a purely causal account, physical causal account. So it's not absolutely necessary. Sometimes you hear it as the suggestion being it's possible to treat neural states as representations, but we regard that as too weak because, as people like Dan Dennett pointed out, you can adopt the intentional stance for practically anything, right? You can say, well, my heart's beating because it believes it should keep beating. So the third option, and the one that we think is the correct option, is that there's an explanatory benefit or some sort of explanatory payoff in our understanding of cognition if we regard neural states as playing a representational role. I think this is the correct way to understand the hypothesis that there are actually neural representations. Okay. Let's talk a little bit about issues of implementation. As I said earlier, we're okay with the basic idea of mental representations that exist at some presumably higher level of analysis. So in a sense, we recognize that ultimately neurons implement representations. But it's really important to see that that doesn't commit us to the view that neural states, as such, should be regarded as representational vehicles. To think that would be to commit some version of what sometimes gets called the mereological fallacy, which is that thinking if a given system possesses some feature or capacity, the component parts, the component elements must also possess that feature or capacity, right? So for example, we know that cells implement our respiratory system, but it'd be completely wrong to infer on the basis of that that cells are breathing in some way or that they should be viewed as breathers. Now, of course, that raises a really important question, which is how do we demarcate the distinction between neural representations in the brain from non-neural representations in the brain? That is, representations at a higher level of analysis. And I tend to think this is actually a pretty tricky issue. It's a little bit complicated, but roughly speaking, it seems to me that the proper answer should focus upon whether or not the relevant activities of the vehicles involve recognizably neurological states and activities, as opposed to more abstract non-neurological states and activities. Are the neurons or neural states as such, with action potentials and synapses and neurotransmitters, are they functioning as representational vehicles? Or is it instead the case that conglomerations of neurons, complexes of neurons, merely implement higher level, more abstract representational vehicles? If it's the latter, then I think we have a hard time seeing why we should treat those things as neural representations. Finally, one final preliminary issue is to just say a little bit about why we think the evidence for representation is actually uniquely hard to specify. So representations, although they're functional in nature, in truth, representation's not a conventional mechanical role, right? Representations transmit information. They inform. They function to designate or stand in for other things. They say things, okay? And these are not really straightforward causal physical relations or states. Functioning as a representation is not like functioning as a pump or a valve or a lever, where we can easily specify the sort of causal relations and physical conditions to look for as evidence for their existence. So consequently, it's hard to know exactly what sort of causal physical conditions to look for as evidence of representation in a given cognitive system. But one thing we do want to emphasize is that if something really is a representation, it really is playing that kind of functional role, it has to be doing something that's recognizably representational in nature. It needs to be doing at least some of the things that we associate with what non-mental representations do, right? I mean, it can't be that anything goes, and it can't be anything goes even if somebody says, well, this is a technical use of the term or this is a special use of the term. Look, scientific theorizing is not a license to use words in completely different and new ways. And just as you can't say, call something a pump if it simply retains fluid, so too, you can't call something a representation if, let's say, all it does is merely functions as some kind of causal relay. Okay. All right. That pretty much does it for preliminary issues. Let's now turn to our problem with the evidence, or how the evidence is often presented in our problem with that. Now, almost universally, almost across the board, purported evidence for neural representations focuses upon the responsiveness of the neural state to stimuli. So for example, in the Pohl et al. Paper, 3 out of the 4 criteria that they treat as evidence for neural representation involve the ways in which the neural states respond to environmental conditions. So one of them is sensitivity. The neural state's activity is correlated with stimulus or feature. There's a specificity in the sensitivity where changes in the neural state are caused by changes in the stimuli or feature. There's invariance where the neural state is not responding to other variables or other stimuli. And then finally, you do get a kind of downstream criterion where the neural state's activity produces useful efferent downstream activity. But the key thing to notice is that three conditions involve responsiveness. And a similar point applies to Thompson and Piccinini's 2018 paper, where they say for representation, a neural signal carries information about external states. The mapping between a range of signals and a range of external states exists, and then the neural states help guide behavior. Well, here two conditions involve responsiveness. So with here, we kind of see a really, I think, nice illustration of what I would consider, what we consider to be the standard outlook with regard to evidence for neural representation. That when it comes to evidence for neural representation, we should focus primarily upon the etiology of the neural state, how it is triggered by stimuli. There is some consideration of the effects it has on the system, like whether the downstream effects are appropriate, but the bulk of the evidential discussion dwells upon how the state is prompted, how it reacts to stimuli. Does it respond uniquely and specifically to specific environmental cues? And how is the neural state in question initiated? That's kind of the basic idea. All right, well, let's just jump right into the problem that we have with this. Our main concern is that this sort of special responsiveness that's described by the authors like Pohl et al., that is responsiveness that carries information about the environment, it's reliable, it's sensitive, it's specific, it's invariant and systematic and so on, that's not unique to representations. So lots of possible non-representational roles would display the exact same sort of reactivity. That is, non-representational roles like a functioning relay circuit or some kind of energy transducer or some kind of causal mediator and so on, those would also involve this same sort of responsiveness. So look, here's an analogy I'm going to keep coming back to in this talk. Like neurons, spark plugs in a conventional combustion engine have a firing rate that reliably and specifically and systematically and invariantly correlates to something beyond them, namely pressing on the accelerator pedal of the car. And moreover, their activity leads to appropriate output given these pedal pressings. But obviously, spark plugs are not playing any sort of representational role. So treating this sort of responsiveness as reliable evidence of a representational role for neurons strikes us as a really, really bad idea. Okay, so let's go back to those sort of conditions that I laid out earlier about the factor that we claim can severely undermine the quality of evidence for given hypothesis, namely the existence of alternative hypotheses. So think about unique compatibility. Our claim is that the special responsiveness is not good evidence for representational hypothesis because it's compatible with various other non-representational causal mediating roles. Or think about this in terms of the prime principle of confirmation. The special responsiveness that's highlighted about these neurons as evidence for their playing a representational role is not good evidence over a non-representational hypothesis because it's not any more likely given the representational role as opposed to some of these other possible non-representational roles. And think about it as well in terms of abduction. Special responsiveness is not really good evidence for a representational hypothesis because the representational hypothesis does not provide a superior explanation over various possible non-representational hypotheses about the primary main functional role that they're playing. Okay, now that's focusing our concern on the responsiveness on the afferent end of things, but what about the efferent end of things? What about what people say about that? Well, I mean, I noted people do indeed include efferent, that is, output conditions as well regarding the effects the alleged neural representation has. In other words, as people like Ruth Millikan have put it, this involves the way in which the alleged representation is consumed. So what does such consumption on these accounts involve? Well, unfortunately, it seems that the same sort of problem arises here. Most of the time, consumption is defined as doing something beneficial, like ultimately generating beneficial behavior, given the environmental condition that the neural state is responding to. Well, once again, that's a role that's shared by a host of other non-representational mechanisms, right? Most functional relay circuits or useful causal mediators will generate appropriate output in light of whatever world condition they're responding to, right? Or go back to the spark plug. A spark plug causes explosive piston motion, which in turn spins the drive shaft when the accelerator is pressed. It's doing the exact same sort of thing. So here again, it seems that the evidence, the alleged evidence for representation, isn't really good evidence because it's compatible with a variety of other sorts of functional roles. Okay, now what I want to do now is just take a little bit of a timeout and take a little bit of a brief tour and sort of point to a bizarre puzzle about the search for evidence for neural representations. I really want to highlight this because I think it really is revealing in certain ways. So um, representation is generally regarded, as John Hoagland repeatedly emphasized, it's a functional type of thing, right? It's a functional kind of entity. It's playing a certain kind of role. That's its defining role. Now, for practically every functional type of entity, the defining aspect of that functional thing is not how it's generated or how it's triggered, but instead it's what it does. It's the role that it plays, the sort of job that it's performing, how it has an impact on the system or has an impact on other things. If I want to look for evidence of something's functioning as a doorstop, I'm not going to look at how it was created or how it was generated. I'm going to focus upon whether or not it has a certain impact on doors, whether or not it's holding open doors. Why then, in our search for evidence for neural representations, have investigators focused so heavily upon how the neural state in question is triggered or caused? Why focus on the neural state's reactivity to stimuli and not nearly as much on the nature of its employment or its effects on the system that it's a part of? Well, this is pretty speculative, I'll admit that, but here's kind of a speculative answer, and it involves two sort of implicit or tacit assumptions that we think are out there. One is that I think people believe that content is more or less a defining feature of representations, and people think that possessing content can be reduced to possessing information arising from triggering conditions. So let me try to explain all this. First, as a lot of you know, especially in the philosophy of mind, a major element of our efforts to explain cognitive representation for roughly the last 40 years has been an attempt to provide a naturalistic theory of content. So content, as you know, is the relation between the representation and whatever is represented. It's what, in a sense, the representation is actually saying. And a naturalistic account is one that explains content by appealing to only natural, causal, physical relations and conditions, the kinds of conditions that are respected by science. So for many people, content is treated as the thing that converts an ordinary physical state, like a neural state, into a genuine representation. In fact, content is given such prominence in these discussions that it's basically treated as the representation maker. Secondly, many people try to provide accounts of content by focusing on relations that carry information, like the correlations that arise from how a given neural state is triggered, how it's caused, or how they selectively and reliably respond to environmental stimuli. So notice, if you think that neural representation arises from head world content, and if you think head world content arises from information grounded in how a neural state is triggered, how the firing is triggered, then you're going to think that evidence for neural representation should mostly come from how the neural state is triggered, its responsiveness to stimuli. And I think that's where these assumptions come from. However, John and I think that this is basically wrong-headed. We do not think that content is the representation maker, And we do not think that content automatically arises from information carrying. So first off, as I've recently argued in a recent paper having to do with the problem of content, the idea that content grounding is what makes something into a functional representation, it seems to me, gets everything exactly backwards. Instead, I think the right way to look at things is that something's functioning as a representation is what converts some natural relation, like correlation or causation, it converts that natural relation into a content relation. The search for evidence for representation should be a search for representational functionality. Moreover, secondly, I think everything is an information carrier. It's important to keep that in mind. Carrying information is no big deal. It simply means that you possess properties that entail facts about other conditions. And since practically everything reflects something about the forces or fields that act upon them, then basically everything is an information carrier. What matters and what we should care about is having the function to carry or relay information, having the information itself exploited in some way. That's what is needed for genuine content, for something to be actual representational content. A relation becomes content not when it involves information, but when the information it involves becomes essential to the functioning of one of the relata, namely the representational vehicle. Okay, so moreover, I think this often gets lost, but it's really important to recognize that a natural relation can be exploited by the system and be critical for something's functioning, and that natural relation can also relay information, and yet at the same time, that information itself can be completely irrelevant to that thing's functioning, to that thing's functional role. So for example, going back to the spark plug, the causal link between the gas pedal and the spark plug, it embodies information, it carries information. The firing of the spark plug could be used to learn facts about the gas pedal. But in its normal functioning, even though the spark plug's proper functioning exploits this causal link, and even though that causal link relays information, the information involved is completely irrelevant to what the spark plug is doing, to the spark plug's job. The spark plug is an information carrier, but it's not functioning as an information carrier, and therefore it's not a representation. So the bottom line is that exploitation of an information relaying or carrying relation is not, in and of itself, evidence for representation. Okay? So the upshot of all this is that the search for evidence for representation at any level of analysis should focus on what the alleged vehicle is actually doing, what sort of role it's playing. It doesn't really matter that it carries information, or that it exploits some information-carrying relation, or that it responds to stimuli in a certain way. What matters is how it's actually being used by the system. Is it performing a recognizably representational role? Is it performing in a recognizably representational manner? Is our understanding of the system substantially enhanced by seeing it as playing a representational role, as opposed to some other causal mediating relay circuit, some other role? The focus really should be on those downstream efferent relations, the impact it's having on the system, how it's being employed by the system. So that's kind of a main issue basically for us. Now, I have said that people have brought up efferent relations as part of the criteria for evidence for representation. And I don't want to pretend that like they don't ever talk about functionality, or they don't ever want to talk about representation consumption. However, when you look at the kind of downstream effects that are often presented as evidence for representation, these are often, we think, too general and not specifically or not sufficiently specific for representation. Like, for example, simply promoting appropriate behavior given the relevant environmental condition. So there's lots of different sorts of examples of this. So let me just sort of talk about one really recent, I think really valuable, really important book on this. It's Nick Shea's book. In that book, Nick talks about what he calls the evidential test for when representational content as such is exploited by the system. And I don't want to get into too much detail, but roughly the idea is that if you change the quality of the head world relation, if that changing the quality of the head world relation, like some kind of correlation or some kind of structural similarity, has an effect on the quality of the behavior. So you change the sort of what he calls the content relation, and that changes the quality of the behavior. Then for Nick, this he suggests is evidence that what is in the head is functioning as a representation with exploited information. So for example, if you introduce noise into the correlation relation and the correlation breaks down, if that then causes the behavior to break down in certain ways, Nick would say that's evidence that the relationship is being exploited as an informational relationship, and therefore the internal state, the mediator, is a representation. Now, it's kind of the same theme. The problem with this outlook is that the general phenomena of degraded or enhanced input causing degraded or enhanced output is not in any way unique to representation, and in reality is common with regard to a whole array of different sorts of functional roles. Right? So, I mean, getting back to the earlier analogy, if you degrade the connection between the accelerator pedal and the spark plug, then that's going to degrade the car's performance. But that doesn't in any way provide evidence that the spark plug's actually functioning as a representational vehicle. So the thing that Nick picks out as a possible source of evidence for representation really isn't. Another way sometimes in which the downstream efferent influences are promoted as evidence of representation is to simply just treat these influences themselves as a type of imperative or command or prescriptive content. So for example, Thompson and Piccinini suggests, and this is a quote, a state S imperatively represents that P just in case the system that produces S has the function of producing S in order to bring it about that P. That is the system's imperative representational function. So what they're really saying here is that if a state is supposed to bring about some effect in a particular context, then that state represents what it's supposed to bring about. But of course, the problem is that that would make just about every mechanical system into a representational system, right? I mean, the spark plugs would then be imperatively representing the command, piston, move away now. But that's clearly wrong-headed. That is not how we should be looking at things. So here again, the proposed evidence is compatible with other non-representational roles. Okay, now, it's fair to ask, well, what should we be looking for? What would count as evidence, as efferent evidence of some kind of a representational role, or that something is functioning as a representation? Well, our view is that actual evidence should involve findings that, number one, are unique to representation and that would support a representational hypothesis and not other possible hypotheses about the role that anything is playing. So it's got to be unique to representation. And primarily, it should not be focused upon the responsiveness of the state in question, but on its functionality. It should reveal activity that resembles maybe, the way we use representational systems and representational devices. So what would that look like? Well, here's an idea. Suppose someone thinks that some structure is functioning as a cognitive map, and it's being used as a cognitive map for navigational purposes. Well, then look for evidence or look for processing that suggests the system is in some way sensitive to the relations between the elements of the hypothesized map, and that it's exploiting these structural relations of the alleged map, and then inferring similar relations between elements in the actual terrain, right? I mean, that's after all how we use maps, right? You look at the map and you see, well, this thing here is above this other thing. It's to the north of this, and it's to the east of this, and this thing here is between these two things. So you pick out those structural relations between the elements of the map, and then you transfer that onto the actual environment, and you use the map as a kind of surrogate for the environment because you're sensitive to these different sorts of relations. It's exactly what Chris Sawyer refers to as surrogative reasoning. Okay, well, instead of just focusing on the mere homomorphism, focus on how those elements of the alleged map are being used by the system. And if the system is sensitive to these different relations, and then using these different relations of the alleged map to assume similar relations in the terrain. That, it seems to me, could be used as evidence that this thing is actually functioning as a cognitive map, and therefore is functioning as a representation. Another possibility is that, as some of us, myself and Frankie Egan more recently, we argue that any kind of mathematical computation or any kind of mathematical calculation would require that the system treats the inputs and outputs as representations of mathematical entities. Like if something's doing division or multiplication, well, it can't manipulate actual numbers, so what it has to manipulate are symbols of numbers, and those are representations of numbers. In other words, it'd be manipulating numerals. Okay, well, in that case, any evidence that the brain is performing some kind of mathematical computation would also be evidence of there being this kind of what I'd call in my book input-output representations. And in that sort of a story, those kinds of computational operations would need to be viewed as treating their inputs and outputs as representations of things like numbers or other kind of mathematical entities. Okay, so that's something that might serve as evidence for representation. But here's the problem with all of this from the standpoint of neural representation. In all these cases, these operations and these computations would be described at a much higher, more abstract level of analysis as abstract computational operations that are doing things like performing mathematical functions. And consequently, the representational vehicles would presumably be something that's operating or should be viewed at a much higher level of analysis. As I said at the outset, we're not opposed to the idea that cognitive representations exist at some higher level of analysis. We are simply calling into doubt the existence of evidence that representation is happening at the level at which we likely find neurons and action potentials. We believe that the level at which we're likely to find evidence of structures actually playing this kind of representational role is at a much higher level of analysis that involves more abstract computational operations. In other words, if we think there's going to be something functioning as a cognitive map, that's going to be a model or map that's functioning at a higher level of analysis. And insofar as there are operations taking place that are performing mathematical operations or mathematical computations, that too will be happening at a higher level of analysis and not at the level of neuroscience. Okay, let me just wrap up then. Here are some of the main points we've tried to make. At least some of the main types of purported evidence for neural representation are deeply problematic and don't exclusively support the representational hypothesis. Now, of course, there's probably other forms of evidence that people have talked about that are in the literature, but we mostly wanted to focus upon the main things that people are often characterizing as evidence for neural representation and demonstrate that these sorts of findings as evidence, treated as evidence, that's deeply, deeply problematic. We also think that researchers need to do more to consider other possible non-representational roles for the neural states that are equally compatible with the data and the findings. And we need to focus, we think much less on how a given neural state is triggered and much more on what exactly it actually does for the system, the kind of role that it plays. Afferent roles providing representational evidence needs to be specific to the sorts of job representations traditionally perform and not simply be something very general like being beneficial to behavior in some way. Moreover, it's important to recognize that being an information carrier is not sufficient for representation. For representation, something needs to function as an information carrier, and so the evidence needs to be evidence that something is indeed functioning as an information carrier. And then finally, I think people need to stop committing what we call the neural representation attribution error, which is sort of starting from the presupposition that something, a neuron, a neural state is playing a representational role, and then interpreting everything on the basis of that. We need to be open to the idea that neural states play other kinds of roles, and we should just stop with this presupposition that representation is the main thing that neurons do. Okay, thanks.